Lab 2, Charge Tape. The purpose of this lab is to revisit the concepts covered in Lab 1 in order to investigate whether a computational model can more closely model the charge tape lab. Some models and concepts are Newton's second law, the electric field law, electric force, and the superposition. The results and assumptions from Lab 1 as the charge tape was 8.9 times 10 to the negative 9 coulombs, assuming the tape is a point charge and that each piece of tape had an equal charge and even distribution. From Lab 2, the charge ended up being 2.17 times 10 to the negative 9 coulombs with the new model. The system was the upper tape and the surroundings was the bottom tape and the rest of the universe. In the GlowScript code, it can be seen that we used a function to calculate the E field as well as a function to calculate the charge lines which model the tape. We then used a loop and a nested loop in order to calculate the electric charge of each point on the line charge, and then added them all up using superposition in order to calculate the net electric charge, which counterbalanced the force of gravity. The results show that the magnitude of the force was about equal and opposite to the magnitude of the gravitational force, and the value of the charge was 2.17 times 10 to the negative 9 coulombs. This is about 24% of the Lab 1 computed value. So what if we modeled each of our tapes as a single point charge and then compared the estimated value of the charge to the experimental data? So the single point charge came out to be 8.96 times 10 to the negative 9 coulombs. The line charge model came out to be 2.17 times 10 to the negative 9 coulombs. Why do these estimates differ? Which value is more likely to be closer to the real value and why? The line model is likely to be closer to the actual value of the charge on the tape because it is more closely models the experiment by using more than just one charge. These estimates differ because one uses one point charge, which is the most ideal experiment for calculating electric force and fields, whereas the other one uses many different point charges all in a line, which more accurately represents what a charge tape would look like, except with orders of magnitude more charges. In conclusion, the line charge model is a more accurate computational model of a charged piece of tape than a point charge model due to a closer representation of what a charged piece of tape looks like.